converting equivalent forms of rational numbers, all this stuff on here, these are rational numbers. Whole numbers can be rational numbers, fractions are rational numbers. So here's what we're doing. How do you convert that to a decimal? Well, here's what you're going to do. 5/9 is 5 divided by 9. And one little trick, and here's what we're going to do. You will then do 9 divided by 5. And one thing that students have repeatedly asked me is, how do I know if it's going to be this one or if it would be this one? And I have two answers for them. One is you need to know the difference based off when you begin. So when you begin, is this number bigger or smaller than 1? And I think you know the answer is that it's smaller than 1. It's 5/9. So 1 is greater than 5/9. 1 would be equal to 9/9. So I think, like I said, I think you know the difference, but you might not know, when it comes to here. So if you're like, I still don't know which, is it the yellow or is it the green, then here's how you can begin. You start by asking, how many times can we multiply 9 and it gets 5? Well, 0 times, right? And you might be thinking, okay, well, that doesn't exactly answer my question. True, maybe, maybe not. How about the red one? How many times does 5 go into 9? It goes in 1 time. So, and then there's like 4 left over, right? So here's the thing. Up here, 5/9 is smaller than 1. Right here, we're saying this is already 1 with some more left over. So guess what? This is not the one that works. In fact, let's see if I can grab it and move it over. Ungroup. I want to grab this and just drag it out of here. What's going to happen is we know it's less than 1. So this is the one that works, okay, because we have got 0, right? It goes in, that 0 is definitely less than 1, right? So here's what's going to happen. You have a decimal. That decimal is after the whole number, right? And there are infinite imaginary zeros. I guess I shouldn't say they're imaginary. There's infinite zeros behind that 5, okay? And what we're going to do is we say, okay, 0 times 9 is 0. And 5 minus 0 is 5, and then you're going to drop this 0. I'll do it in blue so you can definitely see. Now it's 50, all right? And by the way, this is, part of the reason why there's infinite zeros down here is because we can divide 9 into 5. It's just, it's going to, the pieces, the answer, the result's going to be less than 1. So now we go, all right, so how many times can 9 now go into 50? We know that is 5 times because 45 times 9, because 9 times 5 is 45. You subtract and you get 5. Now, some of you are like, okay, wait, I know what's happening already because we bring down that 0 and we have a 50. And if you're like, but we already had a 50. Wait, we already had a 50. We had a 50. So that is because 5/9 is really 0.5 repeating, okay? And because we're just going to continue to get 5s, and we'll continue to get 45 minus 50, and we get another 0, right? So it's 0.55555, and how we communicate that is we put a bar over the repeating numbers. So number 1 is 0.5 repeating, okay? Let's zoom in on this one. Maybe we can do our work here. One thing I want to show you is in class, I learned something this week. I learned about the box method of division. In fact, why don't I show you the box method just real quick? I'm going to show you the box method as it stacks up to this version of long division right here, okay? So it looks like this. So keep in mind, this is what we just did. Here's the box method. There is 9 on the outside, and then we're going to draw a box. How do you know how big a box to draw? I don't think you do know. But I'm going to just draw a box and start to divide it up. And you can obviously add more boxes on the end if you want to. I don't want to right now. And then 5 is going to go on the inside. Okay. Does this remind you of this yet? I hope it does. So now, let's keep going. How many times can 9 go into 5? 0 times. So 5 minus 0 is 5. This 5 zips up here. And what's going to happen is there are zeros in all of these boxes because we have a decimal right there. Does this decimal after the 5, these zeros, does any of this seem familiar yet? I hope so. Okay. So now how many times does 9 go into 40? Well, I gave you the answer. How many times does 9 go into 50? It goes in 5 times. We get 45. 50 minus 45 is 5. You bring up the 5, 50. And it's just going to, sorry, I started writing that 45 before I wrote the next 5, right? And it's just going to happen again that we repeat it forever. And if you're like, wait, I don't quite understand what just happened here, I'll do a couple more and you'll see it. But again, the answer is 0.5 repeating. Okay. So zooming in here, we got negative 3/8. And we have 8 going in to 3. All right. I'm ignoring the negative for right now, okay? How many times does 8 go into 3? 0 times. We're at the end, so we have a decimal. And we have all these zeros. Invisible. Earlier I used the word imaginary. I meant invisible. 8 goes into 30 3 times. That is 8 times 3 is 24. And we subtract, we get 6. Bring down that 0, and we have 60. How many times does 8 go into 60? 7 times. And we get 4. We bring down the 0, and we have 40. And then you probably know that 8 times 5 is 40. So check it out. We are done. The answer is negative 0.375. That is what 3/8 is as a decimal. So I'm going to do the box method just because, like I said, I showed it to you once. Now I'm going to show it to you again, and hopefully you can kind of see the similarities, and then you decide what you want to do. So we have 8 on the outside of the box. Here's our box. Let's cut it up. We have 3. And if you want to, you can put the decimal now. So that you know, and if you're like, what decimal? This guy, right there. And then you can throw the zeros in there now if you want to. You obviously know we're not going to quite need all that many zeros, but anyway, I set it up nonetheless. How many times does 8 go into 3? 0. So 3 minus 0 is 3, and that 3 jumps up here. How many times does 8 go into 30? It goes in 3 times, that's 24. This is now 6. The 6 jumps up here to be 60. And if you're going, wow, this box is really confusing. This is this. Just in what I would kind of call it's more squished together. This kind of drops down, right? Whereas this is kind of kept in this little sandwich lunchbox, okay? And next, how many times does, so here, actually, my 40 up here is kind of blended into my box. I didn't mean for that to happen. So how many times does 8 go into 60? 7 times 56 minus 4. There it is. Sorry, that should be a 4. And then, it's the same thing, right? It's going to be 0.375. It's just now you've seen it with the box. And yes, it is negative just because of this negative. And the funny thing about the negatives is when you divide, you don't have to worry about the negative at the beginning, but you don't want to forget it either. Now, if you're thinking, oh my gosh, 9.5 minutes to do 2 problems, I explained in detail what's going on and why and all that good stuff, and I did both of these problems twice. It's not going to quite take that long on each of these. But it's at this point that I've kind of said, all right, now you try. And I think what people have gotten lost with is they're still like, wait, is it 11 and then 3, or is it 3 and then 11? Okay. Well, so earlier I had mentioned that in English, this was 5 divided by 9. And one thing that I picked up on when I was a little bit younger was that if I knew that this was going to be 3 divided by 11, then I could literally just start dividing right away. And if you're like, wait, what? What do you mean? The 11 is already outside and it's going to stay there. The 3 will go inside. And now we're ready to divide. So let's do it, okay? How many times does 11 go into 3? 0 times. We have a number smaller than 1, right? Because there's a 0 there instead of a 1, right? Okay, so we have our decimal, we have all of our invisible zeros, and let's start to now ask, how many times does 11 go into 30? Twice. All right, so 30 minus 22 is 8. Bring down the 0. This goes in 7 times, 77. That's 3. Bring down a 0. We got 30. This is a 2. We got 22. This is an 8. Did you notice that we have had 8 already? An 8 already? Oh, and you know what else? We've had 3 already and 3 already. The answer to this is, let me switch colors, is negative 0.27 repeating. So if you were to continue this up here, it would be 27, 27, 27 like that. And it goes on forever. And we put a bar over both of those because they repeat. Both of those repeat in that order forever. Okay. So I did that one with long division. I'm going to do this one with not long division. I'm going to do the box. 30 in the box. 7 in the box. And you know what? Instead of making a whole bunch of boxes, I'm just going to draw one big box and I'll fill it in as we go. So does 30 go into 7? No. Decimal. Our number here is less than 1. And yes, we knew that. Our number is less than 1. And if you're wondering why I'm saying that, it's because it's true. And we needed to know that so that we could be confident with our decimal right here. Okay? So 7 minus 0 is, well, 7, and you bring up the 7 up here, and there's going to be 70 there. All right? Let's go ahead and close off that box. So 30 goes into 70 twice. That's 60. There's 10. I had students who were concerned. They said, we can't have 100 up here, can we? Yeah, why not? Because 30 goes into 100 3 times. That's 90. And then that's 10. And so you bring up this, and that's 100 again. And pretty much, if you have repeating, you need to go ahead and stop, because you are now going to have 0.23. And if you don't believe me, watch. It'll be 3 times 30 is 90. 100 minus 90 is 10. You would have 10. I'm sorry, you'd have 100 again. And oh, look, they're repeating again, right? So the answer for number 4 is 0.23 repeating. The bar is only over the 3, yeah? Because that's the only part that repeats. All right, here's another controversial one. I say controversial because you have some options on how you can do it. You can make this an improper fraction by multiplying 12 and 1 to get 12, and then add 5 to get 17 twelfths. You could do this. And this number is bigger than 1, but we already knew that, right? So what you could also do is just break the 1 off down here and then do 12 divided by 5, and then just make sure and put this right down there too. I don't care how you do it, right? But I'm going to do this version where I've broken off the 12, and now I'm going to divide with the box. Here we go. So there's a 5 inside. 12 can't go into 5. 0, there's the decimal. Now, 5 twelfths is less than 0, and that's why this decimal's here after that 0. Sorry, it's not less than 0. 5 twelfths is less than 1, And this number, since it's 0 point something, means it's less than 1, right? So 5 minus 0 is 5, and that's 50. By the way, if you're getting annoyed with this being 5 and then 50, you could skip straight to just 50, just make sure and use the decimal. But anyway, let's keep going. What times 12 is less than 50? How about 4? So 48. Oops. That's 2. Bring the 2 up. 20. 1 time 12. That's 8. This is 80 because the 8 goes up there. Let's see. 6. 6 is 72. And that's 8. And oh my goodness, there's 80 again, and we get 72 again, and we get 8 again, and we get 80, and we get 72. So the answer is 1 5/12 is 1.416 repeating like that. So would you get the same thing if you did this? Well, let's see. 17 into 12. I'm sorry. I screwed it up, didn't I? 12 into 17, it goes in once, right? We have a 5 left over. The decimal goes there. The decimal goes there. 0, bring that down. How many times does 12 go into 50? We answered that right here, right? So it still works with 12 and 17. We still get 1.416 repeating. This one is one, it might be the first one that you don't need to do any math really, unless you don't know that 1/3 is 0.3 repeating. So you might be able to answer this problem like this immediately. This is 100% the answer, okay? But if you don't believe me, how many times does 3 go into 1? 0 times. How many times does 3 go into 10? 3 times with a 9. And then there's 1. We bring down a 0. Oops. Right there. How many times does 3 go into 10? 3 times. And we've already started the repeating, right? There's our answer. Negative 13 into 22. Actually, the way I said that was kind of wrong. By the way, notice how the big division bar is, if I just do this, it's a box now, right? There's going to be our decimal because 22 can't go into 13. It goes in 0 times, but it can go into 130, right? 5 times. So that's 110. There's 20. This 20 pops up here. 200. That goes in 9 times. 198, and that's 2. This jumps in here as 20. And that goes in 0 times. By the way, this 9 is kind of bugging me. That's a 9. And what happens is that's, 0 times 22 is 0 minus 20 is 20. And oh, look, we get a 200. So we have a 200 and a 200. And so what's going to happen is we're going to get 9 again, 198 with a 2. And then that's going to become 20, and that's going to be 0. So the answer is negative 0.590. And now here's the part that's a little funky about this. There's a line right there, the bar over that, because what's happening is it's 909090, right? Like that. And you put the bar over the part that repeats, right? Right. Number 8. 5 and 1/6. Now 1/6 is one that is a little annoying, but it kind of, like, you can come up with a pattern with it so that you could be a little less annoyed with it. And if you're like, what do you mean by a pattern? Well, I mean, like, if you have 1/6, we're going to have one certain answer. If you were to add a 6 to that, that's 2/6, or 1/3, and that's 0.3 repeating. And if you were to add a 6 to that, that's 3/6, that's 1/2, that's 0.5. And if you were to add a 6 to that, you get 4/6, and that's 2/3. That's 0.6 repeating. So I was talking about patterns. Let's see what the heck I was talking about. So there's the decimal. Let me zoom back in over here. This is now 10. 6 goes into 10 once. So 10 minus 6, 10 minus 6 is 4. This is now 40. And 6 goes into 40 6 times. That's 36. That's 4. Oh, look, we get 40. So it will be 0.1666666. So 1/6 is really 0.16 repeating. And so if you were to kind of double 0.16, if you were to add it to itself, that's, doubling is when you take something and multiply it by 2 or add it to itself. So you would get that. Well, that's not exactly 0.3 repeating, but the reason it's not exactly 0.3 repeating is because technically I didn't add 0.16 repeating, right? But notice how it's almost that. So here, let's connect that almost. In fact, we'll do a squiggly for almost. And then if I were to add another 0.16 to that, do you know what I get? I get 0.48, which is almost half. Why is it not half? Well, because I didn't add infinite 6s to it, and I didn't add infinite 3s, right? I added a 2. So technically speaking, if you wanted to, you could be out here 0.33 plus 0.16. That's 0.49, which is a little bit closer, right? And then let's do it one more time. Let's add 0.16. Why 0.16? Because that's 1/6, and that's what we were doing here, right? Okay, so we get, that's a 4, carry the 1, we get 0.64, which is almost 0.6 repeating. And I'm going to say it one last time. Why is it not exactly? Well, because we didn't add that exactly, nor did we add that exactly to that exactly. If we did something closer to it, it would look like this. It would be 0.5 plus 0.16, and we would get 0.66, which is a whole lot closer to 0.6 repeating, because it at least repeats it once, right? So anyway, that's what I was kind of saying with, when it comes to 1/6, you could think of it in terms of a pattern. And you know what? Technically, we could have gone from 3, the 3 repeating, and divided it by 2 to go backwards, but that would be a whole thing. So our answer is 5.16 repeating. If you're wondering where did the 5 come from, it was right there. And the 1/6 was, well, was us dividing it there. All right. So it's been 20 minutes. If you're freaked out, I have talked heavily detailed about these 8 problems, okay? It would not normally take that long to do these. Now we're writing decimals as fractions. If you were to read this, it is 7/10. Now I realize that you would probably say it, oh, that's 0.7, 0.7. But that is also 7/10. And now if you were to write 7/10, well, there it is. That is the answer, 0.7 as a decimal. And if you're a little lost, check this out. If I were to start writing numbers, 1, 21, 321, 4,321, 54,321, but wait a second, what about the decimal? Well, so it's, if I were to start here, 1.1, or 1 1/10. In fact, here, let's do 1 2/10. 1 23 hundredths, 1 234 thousandths. And if you're like, wait, why would that be 4 thousandths? Well, it's thousandths in that direction. Look, this is the ones, tens, hundreds, thousands, right? Same thing in this direction. This is the ones, this is the tenths, this is the hundredths, this is the thousandths, and notice it's 1/10, 1/100, 1/1,000, right? So this one, we can just answer it right away. It's -3/10. And if you're wondering, are they all going to be that easy? No, because we would maybe have to simplify. But the first 3, we do not have to simplify because they cannot be simplified. Oh, look, one that can be simplified. This is 52 hundredths. Now, either you see what number they can be divided by right now, or you can think of a small number that they can both be divided by, like 2. So you divide them both by the same number, otherwise you are not simplifying it. 52 divided by 2 is 26. 100 divided by 2 is 50. And then we can actually keep dividing. Divide by 2 again. So does that mean we could have divided by 4? Yes, we could have. But did you see that? Well, if you didn't see it, then don't worry about it. 13 over 25 is our answer, because 13 is prime. 25 is not prime, but we can't divide 25 by 13. Next, number 13. You might know that 0.25 is 1/4, but if you don't know it, it is 25 hundredths. And both of those can be divided by 25, which is 1/4. And then if you're like, is that the answer? The answer is 1 and 1/4 because of that 1 right there. 14 is -2 and 7 hundredths. And we're done, because 7 is prime. Number 15 is 4 and 18 hundredths. This can be divided by 2. That can be divided by 2. We now have 4 and 9 fiftieths. And we are done. 16, 3, and I got to tell you, we did examples and notes. I did not do the notes aside from this, because I'm kind of including this as your notes. If you didn't see the notes, then this is 10 times better than notes, because I'm going through every single one, and hopefully you're getting it. Anyway, we did ones where 1/8 was the number we were dividing. Guess what? It's 0.125. If you don't believe me, this is 3 and 125 thousandths. We can divide by 25, and we would get 3 and 5 20ths, which can be divided by 5 again. Okay? And that means we get 3 and 1. 3 and 1, 4. Hang on. That's not 20, is it? It's 40. Where's my green? Here's my green. That's 40. So when we divide that, we get 3 and 1/8. There we go. So next, complete the statement. Which one's bigger? Which one's smaller? This one is -2.4. How do I know? 4/10. So which one's bigger? This one is bigger. It is closer to 0. Basically, think of it like this. This guy's lost $2.40. This guy's lost $2.45. He has lost less money, which makes him closer to 0, which means you're bigger when you're closer to 0 on the negative side. This one is -3.3 repeating. We know because we did one with 1/3 right here. And so this one is -3.3. This guy is closer to 0. He's bigger. This one, okay, we got to do a little bit of math here. We could do common denominators if you want. We could convert to a decimal if you want. That's your call. I'm going to go ahead and do decimals because that's kind of been our assignment, right? But you know what? This guy is not reduced. If I divide both of those by 3, I get 2/3. And then I can do this math in my head. This is -5.6. How do I know that? Because this can be 6/10. And if you're like, Mr. Math is going crazy right now, if you were to multiply this by 2/2, it's 6/10. This is one of the little tricks about dealing with fractions, is that sometimes you can convert them into things that you know a little bit better by just multiplying. But I also happen to know that 1/5 is 0.2. So if I happen to have 3 of those 0.2s, That's 0.6, okay? So we got the left side. What about the right side? Well, 2/3, well, hang on. 1/3 is 0.3 repeating. 2/3 is 0.6 repeating. So I have negative 5.6 repeating. Okay, which one is closer to 0? Why are we asking which one's closer to 0? Because on the number line, here's 0, and here are the positive numbers. And what we have is negative 5.6, and right behind him is negative 5.6 repeating. So, did that answer your question? That one, this one is bigger. Okay. Your teacher, you be the teacher, your friend writes negative 7/11 as a decimal. He gets that. Are they right? Are they wrong? Let's see. 11 into 7.00666. That's a 4. That's a 0. That's a 3. That's 33. That's 7. That's a 0. It is exactly negative 0.63 repeating. You did it. And explaining our reasoning, there it is. We did it. Okie dokie. In football, a completion percentage is the number of completions divided by the number of passes. Does Tom or Ian have a higher completion percentage? Well, this is a little bit of a challenge problem. I hope you try the challenge problem. Fractions work where we have a number on top and the bottom number is like what makes it the whole thing. So what we've got is somebody threw 10 passes that were caught. Tom threw 10 passes that were caught, but he threw 22 of them. So this is the number out of how many whole or total throws, right? And in fact, I don't get it. If we have half a pizza, it's like, hey, you have one actual piece, but how many pieces would it take to make a whole pizza? Well, it would take 1 and then 2, right? So anyway, we're at 10 out of 22 is Tom. 10 out of 22. So then I think you can pretty much follow this. Ian, I don't know where the heck Ethan came from, is 9 out of 18. Well, if you learned anything by watching me do this one, you're going to look at these fractions and go, wait a second, I can convert this stuff. 9/18 is 1/2, meaning Ian threw for half or 50%, right? And I know that it does say, who's got a higher percentage? And you're like, how do I convert to a percent? Well, it's right there, 50%, right? And you're like, well, where was the 0 at? It was there. Those are invisible. There are infinite amount of zeros after you write a decimal, but we don't write them all the time because we don't need to all the time, right? It doesn't help. And then this one right here, 10 over 22, if I were to divide that by 2, I'd get 5/11. And let's see, as I'm looking at this has got to be less than half, because what would be half if we were talking about 11ths? Actually, that might be a little confusing to you because half of 11 is 5.5, and this is smaller than half. But here, maybe we talk about this one. What's half for this? Well, if he had gotten 11 out of 22, that would be half. But guess what? He doesn't have that many. So Ian has more completions. He's got the higher completion percentage. And that is our lesson on converting between equivalent forms of rational numbers. So yeah.